x. So remember, an x-axis is located on a what?
A graph.
On a graph. We don't have a graph here.
Yeah.
We don't have an x-intercept. We have an x value or variables here, right? So yeah, we're adding one there. But I want you to look again, right? This is where we're adding, right? So is 16 times 2 8? Okay, so it is dividing-ish. Is there another way to rewrite or to write division by 2? Ah, we can use our reciprocal. Remember those multiplicative inverses that y'all hated me talking about because you're like, oh, Mr. Kinney, can't I just do division by 2? Well, yes, but in the case like this, you want multiplication. And I didn't ask you to write an equation, but we're going to look at this equation in a second. Everybody good with the fact that we're multiplying by 1/2? Any questions about that? So if we're repeatedly multiplying, first off, not in terms of functions, but just in general, what operation shows repeated multiplication? An exponent. Because remember, all I said was not in terms of a function, just in general, what operation shows repeated multiplication? And it's an exponent, right? So what type of function is this? Exponential, right? Did we go back to our notes on dream job salary to help answer this question? Kinda, some of us. See, a whole bunch of us with blank desks, so that tells me we did not. Right, use your resources, ladies and gentlemen. All right, I'm going to ask bell ringer questions built off of the lessons we've gone over. So how to get out my dream job salary and look at those kind of things. Does anyone remember the general equation of an exponential function?
A equals, or y equals a plus bx, or b times x.
So a times bx?
Yeah.
Like that?
Yeah.
No, she was saying the
Like,
B and the X are being multiplied.
Okay,
The b and the x are being
so the a and the b are being multiplied?
Yeah.
The b and the x.
B and X. Or is the X supposed to be an exponent?
It's an x and yeah.
Just like that.
Hey, what's the name of this type of function, Jakayla? Oh, so where's that variable supposed to be?
Exponent.
There we go, right? We want to remember repeated multiplication is shown through an exponent, right? So we want to keep that in mind. Remember, so what is this top equation? It's for a linear function, because a linear function is repeatedly adding, right? So we start at a y-intercept of a, or y value of a, repeatedly add b number of times, which is why b is being multiplied by x. But with an exponential, we're starting at that y value, the y-intercept, repeatedly multiplying by b, and then raising it to the x. So I do want to point out, what would our a be in this equation?
4.
The initial value.
The initial value, but Anthony just said 4 and not 16. So someone other than Anthony, can you explain to me why it's a 4?
Does it start with 0?
So remember, it's not just the starting value, it's, you talked about the x value is 0, so Michaela, what is the point where the x value is 0? What's that called? The point where the x value is 0.
Slope.
Not the slope, the point. Remember, slope is a rate of change. Say it again, Jakayla. Remember that point where the x value is 0 is our y-intercept. A lot of us miss that on our understanding check. You've got to remember, when I'm talking about the y value, the y-intercept, I need that x value to be 0. That's the y value of the y-intercept. And then what's repeatedly happening?
1 over 2. Times 1 over 2. 1 divided by 2.
Thank you, sir.
I'm bad.
Because remember, right, and I heard some debate about this. I think Kyle asked this question earlier. He said, well, I know we have a constant additive rate of change and a multiplicative rate of change, so what would it be for subtraction and division? You asked that, right? Well, no, what would it be called, the rate of change for subtraction and division?
Oh,
Well, notice, even though it's dividing by 2, how did I write it?
times.
As multiplication. Any division can be written as multiplication, so it's still a multiplicative rate of change. Right?
Yeah.
Subtraction can be rewritten as adding a negative, so that's still an additive rate of change. And so we want to keep those ideas in mind. So there's the equation for that. I didn't ask for it. Let's look at the second one. But again, I do want to point out, right, a lot of us need to be careful. I see people talking about a constant rate of change. I see people talking about additive rates of change here. But again, Yes, there is a constant rate of change, but it's not constantly subtracting. If you were to look, that would be subtracting 8, subtracting 4, subtracting 2, subtracting 1. Is that the same all the way through? So that should tell us that it is not an additive rate of change, or a constant additive at least. Should be looking elsewhere. Any questions about that exponential before we look at the next one?
No.
Thanks. I'm glad someone responded. Okay, so identify the type of function in the table. A lot of us here got linear. I see some exponentials. I feel like right here someone just made a choice. Oh, I know what's happening. Okay, I'm going to talk about something in a second. Those of you all talking about multiplicative rates of change, please look at this table again. That is definitely not multiplying. Really quickly, right here, is that an exponent?
No.
No, that 2 is just written next to it. Do you remember, some of us had some trouble in the calculators the other day when we we named variables, because you can't use the same name for a variable. Well, I used x and y in the previous one, so because I did that already, I had to do x2 and y2 to make them different variables. That's not an exponent if you were thinking that, okay? That's similar to this, which we would read as x sub 2 and y sub 2. It's not an exponent, it's just a subscript identifying which x and y. So what's the rate of change? What's happening here?
It's adding.
Adding 3.
Just on the x, right? Is that the only thing I need for the rate of change?
No, you got
It's
it.
adding
side.
5 plus 5 on the y.
We need to be careful.
It's
Is
subtracting.
it plus 5?
It's add subtracting 5.
Or, yeah.
So we need to pay attention to that, right? Okay? And so this is a detail a lot of people miss on the understanding check, which is why I'm bringing it up now. I had a lot of students write this, negative 5x plus 3.
No, it's
Hold on. That negative 5 and that plus 3, is one of those the y-intercept?
yes. No, 7 is y.
Okay? So Anthony's gotten really involved here, but Kiwan, can you explain to us why this 7 is the y-intercept?
Because
Because the slope is 0. The point is 0.
So the whole point's not 0, and we do want to remember, not slope. Remember, so I'm going to come back to you in a second. Slope is the what of a line?
Rate of change.
The rate of change, right? Is that a rate of change? No. I see a rate of change involved here and here, but that's not a rate of change. And notice the whole point's not 0. What is 0? The x value. Remember, when the x is 0, right, that point 0, comma 7 is going to be my y-intercept, right? So here's the x value of negative 1, here's the x value of 1. So when the x is 0, that's when I have found my y-intercept, right? It's intersecting the y-axis there. So you can't just do this. You have to identify this. And so you'll notice on your understanding checks, you should still have them out, because we're going to go over a couple of details. Miss Courtney, I forgot to ask you to pass out my solutions, didn't I, to them? Can you pass those out while I go over a couple of details? So you'll notice, are there just, is there just a score on this understanding check?
You gave feedback.
I gave you feedback. Now, are there scores on there?
Yes.
Yes, and we'll give you a blank copy. I don't think you were here when we did this. So, really quickly, I do want to point this out. When you miss a day and you miss an understanding check, it is your responsibility to come in and make up that understanding check. However, what I will do is, if you miss a day and you never make it up before I give the understanding check back, it's going to be a 0 in the grade book for now. Remember, if you made a 20% on this understanding check, but you make an 80% on the same questions on the test, what's going to be in the place of that understanding check? An 80. So if you have a 0 because you never took the understanding check, whatever you make on the test is going to replace that grade. Does that make sense? So learn from our mistakes, grow and get better.
I got it backwards.
Hold on, let's pay attention. So, actually I'll talk about this in a second. But we should notice this equation would be negative 5/3 x plus 7, right? Change in y divided by change in x times the x, that's my slope, and then plus 7. You could have also done 7 minus 5/3 x. That would have been an option as well. So, let's talk about the understanding check, because this will give us some time to talk about, that's January 19th, that's not today. Alright, so here's our agenda. Remember, always pay attention to what we're trying to do, so that you know what we're trying to learn. So, we're going to do a quick glance at our understanding check. You'll notice in the future that I use the abbreviation UC a lot. When I say UC, what do I mean? Understanding check, right? Again, I don't call it a quiz because a quiz usually means that's the end of that learning and you move on. No, we're going to keep learning this stuff and growing and getting better before that test. I don't care when you learn it, I care that you learn it. So we're going to do a quick look at the understanding check. We're going to wrap up Gold Rush to understand quadratic functions better, and then get into a Desmos activity called Forms of Quadratic Functions, which is why I emailed y'all last night asking you to bring your textbook. If you didn't, I will look out for you, but I do need you to start bringing your textbook Monday. You definitely need your textbook, volume 1, not both volumes, volume 1 starting Monday. Okay? So, quick reminder. First off, is there a final grade on this understanding check anywhere?
No.
No. I'm never going to put a final grade on your understanding check, which I know is going to drive some of you crazy. Anyone have a guess why?
Because it's not about the grade.
Okay, so 1, it's not about the grade, it's about you learning and getting better. 2, if I put a 72 on there, you're going to look at that 72 and then what?
You ain't gonna study no more.
You're not going to look at it anymore, you're going to put it in your notebook and not even worry about it, right? I don't want you to do that. I want you to look at each question to see how well you understood it. If you're at a 5.5, you crushed it. You showed me a lot that you understand what's happening, right? And some students did earn 5.5s and 6s. But if you're down here at a 2, right, solution or response is not valid. There's a decent start to justifying the correct response, right? Well, if you have a 2, you need to pay attention to that, pay attention to the feedback and other things like that. Any questions about this? So remember, you have this rubric. I think it's bright lime green in your notebook. Yes, Jakayla?
At the top of the one that you just gave us, where it say give 15 minutes, max. It must didn't take you long.
Yeah, you can see it on there. It took me 5 minutes.
It took you 5 minutes because you know you a math teacher.
Yeah, but also look at the level of detail I put in my writing. This is what I wrote in 5 minutes.
Yeah, because you know everything. You're a teacher.
Yeah.
You're supposed to.
I gave you 3 times the length that it took me. How many of you wrote to this detail?
Sort of, kind of.
Sort of, kind of. Sharnavia wrote close to this level of detail, and I believe you have 5.5s on lots of your answers, don't you? Took you less than 15 minutes? All right.
But you can't explain it like everybody.
I'm modeling this for you and giving you an example. Please hear me very clearly. 1, it's an understanding check. 2, most of us had stalled out on what we knew how to do. If you hadn't answered a question whatsoever, it's not like it's going to magically pop into your head. So I'm not going to waste class time and waste your time by letting you just sit there and struggle. That's not productive. I'm going to give you feedback so that by the time you get to the test, you understand it better. Okay? So, I want y'all to notice some things. And I believe Ms. Courtney and I gave some feedback to a couple of students. What are some really important numbers that I showed up here that some of y'all forgot to do? There's 2 numbers that I regularly showed.
The identity.
The identities. Didn't I clearly tell you that I want you to show those identities?
Yeah.
Sure, you sure did.
I sure did, right? I want you to show those 0s and those 1s. And also, don't just write down 0s and 1s. Show them, because you've thought through, hey, that +4 -4, that's 0. Right? Show your ideas, justify these things. Notice, you also don't have to write a ton for every single problem, right? Notice how I made one statement here, and I gave a plan of attack to really justify why I was doing what I was doing. I used inverses and properties of equality to create identities, 0s and 1s, while making equivalent equations. Right? Every equation that I created, or every equation that I got, was equivalent to the equation before it because I used a what? What creates the equivalent equations? It's on the board. Just read it.
Properties of equality.
Properties of equality. Whew, thank you. All right. I was using those properties of equality. Now, I will point out this distribution here. That is also a property. It's not of equality, but That's a property, distribution property that you can use. Notice how I did a cut once, I did 2 steps at one time. That's perfectly fine. Notice this is even an extra level that you didn't necessarily need, but what am I doing here in this bottom part of that problem? Number 2.
Plug it in.
So I substituted my answer in to do what?
Check it.
Okay, to check it, to see if it works, to see what? We'll see if what's true. The solution is always true to see if what is true. The equation, right? I wanted to see, does that value make the equation true? With simple problems like this, I'm usually not too worried about it because I'm like, yeah, I can see it pretty quickly. For a more complicated one like this, I was like, all right, let's check it. What did a whole bunch of us forget on number 3?
It's always gonna be the negative one too.
Yeah, when you have a quadratic and you take that square root, is it just one answer?
No.
No, it's both a
Negative and positive.
negative and a positive. If you miss that, where could you go to get some more practice to make sure you don't miss it in the future? Matthew. If you are struggling with any of this, right, can you come into tutoring?
Yeah.
Yes. Can you watch the videos on YouTube? Yes. But at some point, you're going to have to put in the time and effort to do more practice. Go to Matthew. Even once you complete the workspaces, you can do more practice. Take advantage of that. Y'all, a whole bunch of you, I want to address this. Number 4, y'all made this way too hard.
I didn't even make it hard, I just didn't do it.
Look,
Yeah, me too.
y'all didn't even try. But again, were there problems like this on Matthew?
Yeah,
So
but
do
that's
some of
why
us
I
need
took
to-
so long.
Do some of us need to, this took 2 steps.
I'm talking about, that's why it took me so long. I think what it is I get thrown off because it's a
Well, I ain't
whole bunch
learned
of
on
letters.
that.
Yeah, yeah, cause they all letters, that's what got.
There's a whole workspace, actually 2 workspaces, devoted to what are called literal equations where there's just variables. That's it. Okay? If you were struggling with that, go to Matthew. But I want you to notice right here, a lot of you distributed. Is distribution okay? Yes. But remember, we're trying to solve this equation, which what are we going to use? It starts with an I. Inverse. What's the inverse of 1 divided by n?
N divided on 1.
So remember that's multiplying, so I'm going to use the multiplicative inverse. If you understood your inverse as well, notice I'm creating a 1 there. Once I'm left with 1 times a plus bx, you could have just written that as a plus bx. And you just can't forget what you're trying to solve for.
Hey.
I'm trying to solve for a. What's happening to a?
You didn't add it.
Added by.
You did it.
So what's going to undo that addition? That creates a 0. What's a plus 0? 2 steps.
I did. I
Use
had-
your inverses and your properties of equality.
I used my
Doesn't
inverse,
change.
and then I divided, then
I saw.
I
I gave you
Okay,
feedback.
so you said it was okay if I'm distributed first. Can you
Show you what it would look like if you distributed?
you show us like it?
Yeah, if you distributed first, right? So you would distribute 1 divided by n times a. Now y'all need to be careful, because this is one thing I did notice. A lot of people are trying to put that a in the denominator. Are you dividing by a?
No.
No. This is why I also ask you to understand that it's 1 divided by n, because if you do 1 over n, you just magically do things that you should never do. Quit doing that. It's 1 divided by n. I'm multiplying by a. Remember, a is understood to be divided by 1. Plus 1 divided by n, bx is equal to s. Again, I'm trying to solve for that a. A is being multiplied by 1 divided by n, then added by this. So I would subtract all of this. That's going to create a 0. Now what do I need to do to finish solving for a?
Negative 1 over n.
Say that one more time.
Negative 1 divided by n.
Like subtract?
Oh, right there, yeah.
Subtract here?
Nuh-uh, you supposed to multiply n over n divided by 1.
Remember that those are being multiplied, so I want the multiplicative inverse. And I would want to distribute.
Again?
Well, you need it, so remember, whatever you do to one side of the equation, you have to do to the other, right? So I'm multiplying by n, so I gotta multiply everything here by n. So a is equal to, that'd be s times n minus n times 1 divided by n bx. That creates a 1. That is not the way I recommend it, but does it get us to the same answer?
That's the wrong way.
Yep, that's why I did the other one. I use inverses whenever possible. The only time I ever really distribute is when I'm dealing with numbers. Okay?
This is a little bit more practice.
It
That's
just
why we
threw
have
me
this.
off.
Huh?
It just threw me off.
But again, like Matthew is there for us to practice. These last two questions, I want y'all to notice the level of detail that I did here. And again, this is why I said 5 minutes, I'll give y'all 15, because realistically, just answering the questions, I could have done it in 2 to 3, but I justified and showed my work, which is what took me up to 5 minutes. Writing takes time. Okay? So, I want you to notice, the very first thing I did, which a lot of y'all did, was identify the fact that there's a rate of change here, right? You want to know what most of y'all skipped that prevented you from then getting the right answer? If you know it's linear, what?
Do you know what equation you use?
I wrote that equation.
That's as far as I got. I read the
Okay.
equation.
So we got the equation, right? But then that equation should trigger something in us. What is m? How do we calculate it?
Slope is change of y divided by change of x.
Oh, now I can see my change in y, and I can see my change in x. M is 7/3. Notice it's not 7x plus 3 or 3x plus 7. The m is 7/3.
That's why I messed up it.
And then notice how I identified my b right here, because I knew, hey, my x is 0.
I got 3 over 7. Because I thought 8
Because you
was
did
on 8.
x divided by y. But remember,
Yeah.
what's the first way y'all ever learn slope? Before you learn changing y divided by
Rise or
changing
run.
rise
Oh, divided by run.
divided by run. Remember, if it's rising, then x or a y direction.
Wow.
That's y. And if it's running, it's
8.
so pair those ideas together.
I had wrote down the y equals mx specifically because I knew there was a limited thing, but I didn't write down the m equals change in y divided by
But
change.
notice, like when I see that equation, it should make me think of this, which is going to help me get my answer. Right? So notice that's what I did is I used these equations. And if you just wrote down the y equals mx plus b, did you get some credit? Yes. If you just wrote an equation without starting here and your equation was wrong, did you get credit?
Yes.
No.
No.
Why would you get credit?
You're just writing an equation without any justification and you getting it wrong is that -1, right? You came up with an answer, but no justification. Look, I'm looking for your thinking. I need you to explain these things. Alright? So, I am not always going to give you my solution key. I might to help you study and learn from it. But I am always going to give you actual feedback. I'm going to give you scores so you can learn from your previous mistakes. Learn from this. Practice. Can you rewrite these problems on a blank sheet of paper and try it on your own and see if you get the right answer and compare it to my work?
Yeah.
Yes. Can you go on Matthew to get practice with the things that you did not do correctly?
Yeah.
Yes. Okay. Do what you got to do to learn. You can come into class or into tutoring. You can come in or watch videos on YouTube, things like that. Any questions before we continue? Okay. By the way, I do want you to notice, what is a lot of this score based on?
What's your justification?
What's your justification?
You write down what you think.
Explain why you're doing what you're doing. A lot of your score is based on, hey, Ishmael, you know that you get to keep that paper, right? Okay. Yeah. Yeah, that copy's for y'all. Okay. So I want you to notice, right, the justification is what's important. One of the things that I recognize, that I know that not all math teachers recognize, is a whole bunch of y'all are not going to use this Algebra 2 content for the rest of your life. Some of you will, so you need to learn it. But what are you going to use for the rest of your life? Your ability to justify why you're doing what you're doing. Your critical thinking. Your writing. All of these are concepts that you need to develop and get better at, and I'm trying to support you in doing it. Also, I will say, students last semester, especially my geometry class, they bucked at this idea at first, But then, by the end of the semester, I would say about 5 or 6 of them, which honestly, that's impressive in my opinion that they thought about this. They came up to me and they said, actually I think it was in a TI Inspire survey question I sent out. They said the best thing you did for me was force me to do this because it forced me to learn the math better. And that's true. When you know that you have to justify and explain, you're going to have to learn the math better to be successful, and you're going to be better off long term. So we're going to get back to the Gold Rush task. Hopefully you already have that out. I will resend out the file to your calculators while you're getting that document out. Can I get a quick show of hands if the file did not pop up in your calculator? It's only showing that it's sent to 20 of 26 students.
I ain't get it.
Okay,
KYE.
thank you. J-A-I-K-Y-E.
L-A-A.
Alright, anybody else not get the file on their calculator? Nobody else? Alright, well then go to browse and see if the document's there. Alright, so we're getting back to Gold Rush. Remember what we're trying to do with this Gold Rush task is not just figure out what the largest area is, we're trying to learn about what type of function.
I got it.
Quadratic functions. And what about quadratic functions?
Their rate of change.
Rates of change.
And tables.
Tables.
Graphs.
And equations. The algebraic representation, right? And we want to start on writing those quadratic equations. And so, right, we got to this, and I believe we started here. Where did we end yesterday? Do you remember? I think I told you that we're struggling and you need to create a table, right?
Yeah.
Okay. So, you need to make sure that you have a table created on your calculators, alright? We're going to help support you in making sure that you know how to do that and do those features. Quick question, who doesn't have a table in their calculator already? Y'all do not? You weren't here, that's right. Yes, I'll give that to you in a second, okay? Okay, so everyone else has a table in their calculators? Alright, I need y'all to hear me very clearly on this. Hey, eyes up here. Stop and pause and eyes up here. If you thought you had the table and you didn't, let us know, we'll help you. But I want you to notice right here. You need to use your table or any other representation, what other type of representations are we looking at? Graphs and tables and algebraic, which are our equations or expressions, right? You have to use those to completely justify the dimensions for the largest plot of land. You need to develop thorough and clear evidence that supports your answer, and you need to explain how the evidence supports your answer. Once you finish number 2, you need to go to number 3 on the back and pay attention to what's happening there. And if you finish all of that, then you need to try to think about other representations, how you can use the calculators for those representations. Any questions about what we're doing on the Gold Rush task?
No.
Alright, I'm going to give you all 20 minutes to complete this number 2, because you should already have those tables done. Complete number 2, justifying your answer, and then work on number 3, and then we're going to come back as a whole class. Any questions? Let's get to work.
Yeah, I can't do that.
What just happened? Yeah. Wait.
I used to take that.
Let me see,
Where did you get these numbers from? But,
on the outside, only on the outside.
so, because here's the thing, what's the lowest base? Zero, right? So let's, I'm gonna delete.
You get,
47.
it's getting 50, it's getting 50, right?
So let's say that we have a base.
47.
No, we're not.
100.
I know, but
As long as the outside. They cut.
so I'm gonna call this base 1.
Plus 47, plus
Um,
3. That's 100.
Can you get the paper for Allie and make sure she's understanding how to use the calculators?
What paper?
The garbage tax, she wasn't here yesterday.
What are you saying?
Dude, listen. As long as the outside is 100, it don't matter what's in the area.
So what are your numbers?
Yep, I'm aware. Been aware of it.
What are your numbers?
47 and 3.
47 and 3.
Okay.
So, look, I agree with you that it is very similar to what we're doing yesterday, but remember, the lowest base you can have is 0, right? What's like another good value you can use for the base?
He
For the
right,
base,
but 47 plus
yeah,
1
you can
is
put a formula in
Right,
there.
so what are you doing?
We
You
know
are
that.
adding 1. If your base is 0, what's your
That's
last?
maybe. That's to get the area.
So you can tell
It
it.
don't matter what's in the area, as long as the outside is.
The whole thing
Oh, yeah.
was that we had 100 yards, 100 meters of road.
Whatever's in this for the previous box.
And so if the base was 1, what's the height? It'd be 49,
You can-
right? Because remember, the base height had to be a total of 50, because then we'd have it a second time.
So it's just going down every time.
So that's going up by 1, and that's going down by 1, right? And so continue that. And I will say this, if this starts at 0 and this starts at 50, what's this gonna end at?
Let's put it at 50.
It's gonna end at 50, and the height's gonna end at 0. Makes sense? So how do we calculate area?
No, look, I mean, the perimeter is
Based on height, so could you
That's not
do
just
that base times the
We
height
know that, we know the perimeter.
for there? But I'm saying you can write a formula for that too. The calculator.
Area pass is
Mr. Kenny?
Yes.
Okay then, that was start listening to me. That was start
Whenever
listening.
you're
You
putting
can create your own.
Probably.
No, it's something.
No, I said the area, I didn't say that.
See,
See, I said, I said,
So I don't know why that's the cost.
we're not adding
That's
That's not the area, that's the perimeter.
Control plus page.
Dude, that's what we're trying to tell you, that one ain't good.
And then you can scroll up.
Okay.
Oh,
Scroll up.
yeah.
We gotta do it
Highlight
quick.
that box.
Come on, we gotta do it quick. What?
There you go.
Alright, get the area go.
I know you don't put it. Look, right here. 0 times 50. Okay. What's 2 times 48? 96. What's 3 times 47? You literally already had an area over 100. What can't go over 100? Right. Remember, the distance around can't go over 100.